And now we come to one of the best modules of all, and this is Apache KUDO. This is a great time to actually kind of get off the generic bandwagon and talk about Day2IQ's incredible leadership. We have many contributors to Kubernetes, designer of Helm, and other things, and we have learned over the years from orchestration and cluster management requirements that we have, in addition to the low-level containers that we are bringing to bear for Kubernetes. So we have already deployed in this workshop some applications, but they're very simple. They don't require other things. They don't have complicated life cycles. It's possible to run a Jenkins server in a single container by itself. Of course, there can be more complex configurations for even that software. Think of all the legacy full applications that we already have out there that rely on states of other software already running and that have their own mechanisms well established for deployment, quiescing, resuming, upgrades, configuration management, and so forth. How do we deal gracefully with those? One option in Kubernetes is to take that entire lifecycle management, including deployment and upgrades and restarts and all that, and rewrite everything in code. In Kubernetes, of course, it's often Go code. KUDO brings the capability of doing all of that, including conditional logic required, purely in a declarative form. KUDO stands for the Kubernetes Universal Declarative Operator, and we will see how we can manage all of this purely in configuration, in this case YAML files. We accomplish that in KUDO by declaring execution plans, which we will see. We're going to deploy a stateful application which requires orchestration, so ZooKeeper then Kafka. Kafka requires a working ZooKeeper quorum. We're going to show the usefulness of a purely declarative means of controlling software lifecycle using specification, not Go code. We have a section for resources. I would highly recommend going ahead and bringing up the kudo.dev website, kind of the beginning starting point for all things KUDO, and pointing out that we've got the GitHub repo in KUDO Builder, both the KUDO code and the operators that are all open source. And there are the community Slack channel and other community resources are actually also listed on the KUDO Dev site. So let's get started. Our participants need to have that operators directory from the GitHub. So if they use Git, they can simply clone the operators repository. Probably that will work for most of our folks. Let's do it in the Cloud Shell here. And actually, let me do it in my home directory here. All right, so we now have an operators directory with various things for our different software. So that includes Kafka and ZooKeeper, which is what we will be using in the workshop. And if they don't use Git, then they can go to that very same GitHub repo and just download the zip file. Next step, there are 2 steps to getting KUDO working at this stage as of the beginning of September 2019 at least. It's not part of the Kubernetes project, so therefore there are components that need to go on our Convoy cluster, and there's a binary that we need to download to give us the command extension to kubectl, and those 2 steps are done here. So first of all, we download the resources. Okay, so that this is a standard way to get KUDO on your cluster, and we're using what is right now the current released version of 0.5.0. So let's go back to our shell and execute those commands. prerequisites, CRDs, deployment. In this case, the cluster already has these things deployed. So if we want to check the status of the KUDO controller from the command line, they're given the option to do that. And there we have our controller manager running. Now, there's also a CLI aspect, so the binary has to be on our workstation wherever we use kubectl or kube control. And on Mac, you can use Homebrew. And I believe I already have that on here as well. I do. So the way you test it is you can do these two commands, both of which should return exactly the same result. One is that binary we just downloaded. The other is using it within regular kubectl, so kubectl space KUDO version. Let's give that a try in our shell. And they both give the same expected result. And we include the expected result here for our participants. Now we get to deploy ZooKeeper, which is a prerequisite for Kafka. And what we need is to go to the operators directory that was downloaded or cloned. And so we're going to cd to that and then run the installation command for ZooKeeper. And that looks like this. We go to our operators directory. We go to the repository within there and ZooKeeper. And I believe that we need to go into the operator directory from there. Okay, yes, because that's where our definitional YAML is. So let's give it a try. And it tells us that a particular instance was created. All right, when we go back here to see the status of the deployment, this is where it becomes really interesting, I think, where we see that a planned deployment strategy is in progress. So we've got a couple steps in progress, something pending. As we continue to watch that, we'll see that change to to all being ready. It's a little bit confusing here because there's another plan here for validation, which can show kind of in any order. You can see in two instances of the command execution, they showed up in a different order. We're looking for planned deployment and seeing how that goes. So this now says that it's all complete, so we're ready to go. And to check that the corresponding pods are running, we're not placing these in a specific namespace, therefore I'm just using grep to see these particular instances. And there's our 3 ZooKeepers, which are required to create a quorum. You have 1, 3, or 5 typically. Now that we have ZooKeeper running, we're ready to deploy Kafka. And the way we do that is in a similar fashion as we go over to now the Kafka operator directory, and then we will run this command, which I will copy. We'll go over to our shell, Kafka operator, and we will run the install. Once we do that, we want to look at the status of the deployment. And as before, we see our plan executing. And the one we're interested in is the deploy plan, which is in progress. And we'll just wait until that finishes. And after a couple of minutes, Kafka is up and running. We want to go back and take a look at our instances for Kafka, same type of thing as before. And there they all are running. The next thing we want to do is bring up a deployment that will simply continuously place messages on a Kafka topic so we can read them, we can go into our monitoring and see what that looks like. And we do that as before with the YAML feeding to kubectl. So let's do that. We now have KUDO Kafka generator running as a deployment. And we want to create a Kafka consumer as well to read from that topic. So let's do that portion. Then checking the logs. So next step. So we're not quite ready because we're in a container creating state. Not surprising. I didn't have to wait long for that. So this is kind of like a log tail. We're getting the logs from the consumer as it's reading from the queue. The next part is just looking at how we understand what's happening with KUDO. So the first part is this idea of custom resource definitions, which KUDO is creating. We can get information about these objects with this command. So let's go into the shell and take a look. So we've got several KUDO custom resource definitions out there. So we've got this idea of instances, operators, operator versions, and plan executions. We list the KUDO instances running using this command. So looking at getinstances.kudo.dev. Again, instances, one of those specific CRDs. So we've got Kafka and ZK. And get information about that instance. This is for Kafka. And we're outputting YAML. So the Kubernetes kind is instance. We see the metadata, we see the definition. We can tie these back to the operators that we see within that operators directory, the various YAML files. It's actually quite interesting to look at that within the operators directory, just the resources being used, how they refer to other YAML files, so it's kind of composable into different sections. When you look at things like how do the plans get defined, you have a serial or parallel strategies that might be multiple phases. They might refer to other things. There's typically heavy leveraging of stateful sets. If we look at the MySQL, especially under templates, there are different files defined for aspects of the software lifecycle. So doing a restore, doing a backup, possibly doing a restart. So this is, it's just a very interesting thing to explore, but a bit of a sideline from the workshop itself, perhaps. So we can also take that approach to delete a running instance, but we're going to keep it running. I'm sadly going to have to skip that because I am not getting it working on my current means here. And we'll get information about this upgrade, but that is going to be the same as we did before. And we can add more brokers. Here's an interesting way to add brokers. So this is doing not in a YAML file, but we're actually just including the parameter that we want to change, broker count, and merging that in so it says it's patched. And then to check the status of that plan execution, we see that that is in progress, and we are adding a broker instance. And that completes as well. We want to see all the pods running. we go back and take a look at the pods, looking at Kafka pods. We have now 5 Kafka brokers. And that's the end of the KUDO section. Next is a module involving this very short one, just scaling the cluster up to another node. And after that, we've got the monitoring, including the monitoring of this system that we just installed with Kafka.